Hello, my name is Stefan Raspl, and I welcome you to this presentation of what's new with Linux on IBM Z and LinuxONE, or as it says here, getting the most out of the latest features in Linux and KVM on IBM Z and LinuxONE. So this is a combined presentation giving you all of the latest and greatest features of both Linux and KVM on our platform. As our table of contents here also shows. So let's dive right in, get started with the latest on IBM Z and LinuxONE features and packages. The first thing I want to talk about here is not necessarily a new feature, but rather some important announcement you should be aware of, or not even an announcement, rather something we have been working on for quite a bit, as you can see here on this little illustration on the right-hand side. So this is about the removal of the 32-bit support in the Linux distributions. When we first brought Linux onto the platform, we only had RHEL and SLES, and only the very first iterations of both of these were available in pure 32-bit versions. And after that, with the introduction of 62-bit Linux distributions, the 32-bit support gradually disappeared. So only with RHEL 5 to 7 we had a full user space in 32-bit. Afterwards it gradually was reduced. And where we are right now is that the latest and greatest Linux distribution, starting with Ubuntu 24.04, will not support any 32-bit support at all. And this means that if you're thinking your statically linked applications, which bring their own runtime along, will still work, this will not be the case anymore because we removed the 32-bit support in the Linux kernel as shipped by the respective Linux distributions. So if you have a statically linked application, try to run it on Ubuntu 24.04. This will not work. Likewise with containers, there is a little bit of a misperception somewhere out there where some people believe that containers package everything which is needed to run the respective application. Well, everything except for the Linux kernel. And again, if you take away the respective 32-bit backend inside the Linux kernel, even containers won't help anymore. So this means RHEL next, which is supposed to be RHEL 10, tentatively scheduled for sometime 2025, and likewise SLES 16, and already existing out there, as I mentioned before, Ubuntu 24.04. Neither of these Linux distributions will support any 32-bit applications at all anymore. So do yourself a favor, check your respective containers, check your applications. By now, we believe that there will only be very little applications left which run under 32-bit support, but you never know, and better double check than being sorry later on. So next on, another organizational thing. In the past, we had provided Linux distribution-specific versions of our documentation, at least of some of our main books, most prominently our device drivers, features, and commands book. And this has changed. So instead, what we give you is a single generic book, which covers the latest and greatest upstream level. However, if you look into the respective book, into the respective generic book, you will find that there is a so-called distribution information section. And this section points out what has changed for certain distributions. So for instance, like illustrated in this example, we have SLES 15 SP6 mentioned here. And that means that in this section, the remainder of this table shows you what is part of the SLES 15 SP6 release. So you can figure out for yourself quite easily, we believe, which features you can test there. So at the end of the day, you will still get the respective information. However, you have to look into the respective generic book because we will not do a separate edition anymore. Okay, now moving on to the actual new stuff. So the first one, which we want to present here, is the so-called hybrid dispatch support, sometimes also called vertical CPU polarization. So this is a mechanism which has been shipping for the likes of COS and KVM for a while already. And it took quite a bit of work on our end to make it work with LinuxONE Z because we were changing things in the Linux scheduler, and that's like open brain surgery, if you will. And therefore it took a little bit longer, but finally here it is. So the idea is basically that when you get virtual CPUs, as illustrated right here in your respective LPAR, then these are mapped to physical CPUs, like here. And what happens by default, and that's called horizontal CPU polarization, is that the workload is actually distributed evenly across the virtual processors and therefore the physical processors. And depending upon how busy these physical CPUs down here are, this might or might not work so well. Which means it's not a drama, but you're leaving a couple of percentages on the street basically. So the help is so-called vertical CPU polarization. And what vertical CPU polarization means is we distinguish between so-called vertical high, medium, and low IFLs. And vertical highs are CPUs where we're basically saying you will not experience any steal time. That's where our scheduler logic kicks in. Make sure that you always get as many time slices as you had requested with the respective virtual CPU and therefore the physical CPU. And then what we do, of course, is we make sure that the scheduler prefers those vertical highs against others like vertical lows, where things get very extreme, and vertical lows basically give you no guarantee about running any workload at all. And thereby, we're utilizing our CPUs way more efficiently than we would. And this can be very handy in case you are running your machine at a very high utilization, because this whole mechanism really only shines when multiple LPARs are fighting for the same physical CPU resource. So what it does at the end of the day is, instead of having multiple LPARs try to get the better of a physical CPU, the scheduler and also Prism, they work in cooperation. They figure out which physical CPU should predominantly serve what LPAR, and therefore is a vertical high to that respective LPAR. And you're not anymore distributing your workload among multiple virtual CPUs. You're really focusing most of your work onto a single one, which in this case would be this guy over here. And he will execute most of your workload, and only the not so terribly important parts will be executed on something like this vertical low over here, which basically gives you no guarantee about running any application or task at all. So again, this can give you extremely good performance benefits in case you're utilizing your system to a very high degree. That's where it shines. If you have a system which is hardly utilized or has a lot of free IFL capacity, and I'm speaking here about the entire system, the entire box, not an individual virtual server, Linux virtual server, then chances are you will hardly notice any difference at all. Another thing we did was, and this is actually the beginning of a bigger journey, we're looking into improving the installation experience for our platform. So when you're installing a new guest under CVM or KVM, the experience of installing that is usually pretty good. But when you're installing Linux and LPAR, things are a little bit different. And this is what we're trying to work out here. So when you're installing an LPAR, you need a so-called parameter file. And these files have a very complicated or tricky syntax, chances are you will have something mistyped, or you might have some trouble finding the right or identifying the right constructs, or putting some kind of weirdness in. And then when you try to install, things fall apart, doesn't work, you get some error message, and you can get back to editing your parameter file and give it one more try, and hopefully this time it works. Now you can save yourself a lot of trouble and effort if you use our new Linux on IBM Z installation assistant here. It's available at GitHub, so you can just navigate through a browser to it. You click yourself through a very simple dialog, a couple of web pages, and at the end you are rewarded with a simple parameter file, which does exactly what you need and is guaranteed to have a valid syntax and run well. This is available for both rel and SLES. By definition, Ubuntu does not really require a parameter file in that shape. You can do with a generic one, so this issue of having to manually adjust parameter files doesn't really appear there. But for rel and SLES, this can make quite a bit of a difference. It hopefully serves you very well. Next up is Secure Boot for ECKDDSD. This is a feature we had out for a while now, but we're still improving upon it. Secure boot for ECKDDSD is like the secure boot we did with FCP, basically ensuring that everything from firmware up to the operating system, image, or kernel that you're booting is a legitimate one and has been cryptographically signed and is therefore legitimate. To utilize it, you need to enable it on a per LPAR instance. So here's a respective control on the HMC load panel. You can activate secure boot. And what you need to know is that you need several support. So for one, you need to have a GA 1.5 firmware on your IBM Z or LinuxONE box. And then you need, for basic boot support, a sufficiently high version of S390 tools package, which is indicated in this page accordingly. And then if you also look into things like rebooting or dumping, that under the covers actually does some extra things in Linux on Z, and therefore needs extra support. And that's what we added most lately for /15 SP6 as indicated here. So that was a final piece we put in to make our story complete and provide both reboot and dump support also for that Linux distribution. The other ones had it a little bit earlier already. Okay, on we go. You might have heard about SMCD version 2. I'm not going to iterate everything with all the ins and outs about this technology. In short, it's a great piece of technology in case you're interested in extremely low latency and very high throughput. And at the same time, actually saving a couple of CPU cycles. So it is as fast as you can imagine on our platform as far as networking technology is concerned. However, it is restricted to TCP only. It does not work for UDP, only TCP. And that version 1 had a limitation where the peers had to be not only just on the same box, but actually on the same IP subnet. And we lifted the latter restriction. So now both can be on separate IP subnets, and it does not matter what kind of routers, for instance, like this one here, or what kind of firewalls like this one over here are around. It will always work as long as the two peers can talk to another and are located on the same box. And that is, of course, compatible with COS. So it's great technology. If you have very high demand in terms of latency, I would definitely recommend to check it out. Now, the thing is, for one, we have put out a new performance paper, which is linked here. So that's where you can take a look at the performance numbers yourself. But also, in the best tradition of eating our own stock food, we start to utilize it in our own products, most prominently IBM Storage Scale. So that one was enabled for SMCD. The results were awesome. So we got a very solid performance increase, like double-digit percentage of faster benchmark results. And all we had to do is a single code change, which is the one depicted here. We basically had to identify the respective socket call and switch from AFINet to AFSMC, and that's about it. If that is too much because you don't have the source code available for a respective application, don't worry, we have a so-called preload library and a script around it. So we have a command called smc run, which basically does the same thing on the fly when you run some application. Works like a charm. We managed to get every application so far enabled for SMCD. No problem. And also there were a couple of other scripts, Python scripts, which were adjusted, but that's just something extra because that's what this product basically brought along, right? So there's some diagnostics scripts, for instance, so they had to be adjusted accordingly to use some primitives to get diagnostics for SMCD, for instance. That kind of change. For an end user, things couldn't be much simpler. So all you have to do is you have to make sure you get an ISM device, because these virtual devices here is what gives you all of the power of SMCD. They just need to be available. With SMCD version 2, we greatly simplified the configuration. They just need to exist. That's about it. You do not need to have any additional configuration step there. After that, you install your respective tools. Usually it should work automatically through the dependencies in your package manager. If you want to do it manually, you just do it like here, for instance, like with rel. So you install the SMC tools and the QClib package. That's about it. And after that, you need to make sure to do to set SE Linux from permissive to disabled. That is because SMC sockets are not included in the standard SE Linux policies yet. And that's why we need to do a change here. This might change in the future, so it's not like this is not on our radar. We're looking into this. And that's about it. And after that, like I said, performance was just great, and this with just a couple of software changes. So we think this is a great story, and we hope you are able to replicate that for your own applications as well. But on to the next one. This is now getting into the security realm. And there we have the OpenSSL PKCS11 signing provider. The idea here is that if you are running a signing service, you do not want to expose your signing key more than you really need to. And the safest way to do so is basically to protect your signing key with an HSM. So what you do is you encrypt your signing key with the secure key from the HSM. And whenever you have a signing operation that needs to be done, all you need to do is to send the respective token and the signing key down to your HSM down here, perform the respective signing operation, and that's about it. Costs only very little overhead, but it gives you so much more protection of your signing key, because your signing key is never at any point in time in memory in clear text, and therefore the chances of exposing your signing key unnecessarily, or even worse, somebody compromising your signing key, get extremely low. Another thing which we're very proud of is the master key change protocol for OpenCryptoKey. We take a look first at what this looks today, and it doesn't matter if you're running your adapter in CCA or EPU11 mode. In both cases, the very first step you're doing here, and we have 4 steps to carry out over here, right? And 5 steps to carry out over there. In both cases, the very first step is stop all processes. which implies this is a disruptive operation. You cannot, so far, exchange your master key without stopping all of your operations for which you're using it, which of course is not so great because sometimes you do not want to wait for the next service window. If you, for instance, suspect that your signing key has been compromised, or sorry, your master key has been compromised and you need to exchange it right away, you want to do so immediately, not wait for weeks sometimes till the next service window comes up. So what we did here is we came up with the concurrent master key change support, and it does require a little bit of more coordination. So as you can see at the bottom, these two colored boxes, that's basically describing how it's done. So there's a couple of steps which both the administrator of the high security module and the Linux administrator have to carry out, and they have to do so in a synchronized manner. So first off, this guy over here has to do a couple of steps. Then the OpenCryptoKey admin has to trigger the re-encipher operation, and so on and so forth. So it has to be timed. Those two guys need to talk to another. But the good thing is, if you do so, your usage of the master key can continue all the time uninterrupted. And we think that's really a great story and testament to our dedication towards making sure that our platform is truly reliable and highly available. So on we go, and finally here we are at AI. We'll come back to that in a couple of slides, but just to give you an update on where we are here, what we're basically saying is there's 4 levels of support, if you will. The first level is not supported on IBM Z. That happens sometimes due to endianness issues for the most part. And then there's a couple of pieces of the ecosystem which are enabled for IBM Z. For instance, spaCy, DMLC, XGBoost, things like that, or OpenCV. And that just means they compile and they run on our platform flawlessly, but they could run a little bit better if they were starting to utilize our hardware. The first thing of our hardware the first specialty of our hardware that you might want to take advantage of is SIMD optimization. So that's this level down here. That's what, for instance, PyTorch or the Eigen library have been enabled for. And other packages which we saw in the upper layer, like for instance the Llama CPP, are currently being worked on to get enablement for. And then after SIMD optimization, of course, you can also start utilizing our integrated accelerator for AI. That's another level, and I would say the peak level of support of our platform. This is what we did for TensorFlow, SnapML, and OnyxEmular, which is a compiler for Onyx models. And especially this one is not to be underestimated because a lot of the frameworks out there support the Onyx model format. If that's the case, you can use this model compiler to generate binary code from these models and run them at very high speed on our platform using native machine instructions. So that gives you a hardware acceleration for a whole class of frameworks out there, everything which supports Onyx, basically. Good story for us. But again, I'll come back to this in a moment. But first, let's take a look at KVM on IBM Z and LinuxONE. So first off, availability. Well, KVM has been around for a while now. We start to ship it with Linux distributions, and all of the main Linux distros by now feature some shape and form of KVM support. The most important packages to look for are kernel, QEMU, and libvirt, and they get continuously updated all the time. So that's a really good story for the Linux distributors, and it makes it very worthwhile to update your Linux distribution to the latest and greatest available level. Other than that, we released a new version of the KVM Virtual Server Management book, which is available. Oh, that is a link, a hyperlink. It's just not colored. It's available here. And we did so in late November So, since we only rework the books once in a while, that is still pretty recent from our perspective. This one is a classic, which we point out all the time. When you are defining guests in KVM, we definitely recommend that you make sure you use the right model for this for the respective guests in the guest XML or domain XML as it's called, and that would be the host model. That's what we recommend because it gives you a good compromise between migration safety, right? Because only these two up here are migration safe. The host path-through is not migration safe, so that's why you want to stay away from it. It's just not worth risking a crash of your virtual machine when you're migrating to something where you thought it should work but does not. So you want to take some precautions here and use one of the upper two models. However, the upmost model, which is a so-called predefined one, that's also something you do not want to use because that leaves a couple of features of our hardware platform unused. And only the host model utilizes the maximum based off the current host of the feature set, which is still migration safe. And we always make sure that the respective CPU model is available in all of the latest and greatest Linux distributions that support our latest and greatest hardware. So long story short, make sure you always use a host model when you're defining XML domains, and you should be good. Now, the feature we have been investing most in recent years has been secure execution. The idea is that if you're running a KVM guest, like this one here, right? There's a couple of attack vectors. For one, the administrator of the LPAR, in case he was evil, could try to access the guest memory and steal secrets from there. Likewise, other processes which, for whatever reason, some kind of compromise, for instance, managed to gain root privileges. So in both cases, this guest memory would be at risk. Likewise, some of the guest state is available down here inside Prism. And again, somebody could try an attack based on accessing or manipulating the guest state with the same result. So what we do is basically we're protecting the guest memory, so only the QEMU process itself can access the guest memory, and anybody else will read just some random garbage in case he tries to access the guest memory. So neither of these guys, not the guy over here or the guy over there, would be able to read the guest memory anymore. And at the same time, we also protect the guest state by a so-called ultravisor, which makes that data inaccessible as well. Here's a little bit of more information on which Linux distribution supports this technology. That's all for your reference, so you can read up on it. Again, it's great technology, and we have been investing continuously. And the latest feature we provided for this is so-called Crypto Express adapter support. What we basically did is we make sure that a hardware security module can be attached to a secure guest, and you can be certain that this HSM module is actually the one you have in mind and not just a fake one, like a virtual one which some evil administrator tries to make you use so you can read your secrets. This is absolutely safe to use. So it takes a little bit of extra effort, quite some trickery here, utilizing a combination of storing secrets at various places, but we basically pulled this off, make this available to you, and going forward, there's no use why you couldn't trust an HSM domain attached to your respective secure guest and can feel totally safe about using it. But there's more to it, because when we combine secure execution with AI, we can create a true power couple, as we call it. Because at the end of the day, Whenever you're dealing with AI, it means you are dealing with a couple of valuable digital assets. For one, your data you are trying to apply to the model or base inference on, that usually has some kind of value. And also the model itself, the AI model, is also usually very valuable. You invested quite a bit in obtaining the base model most of the times. You had to optimize it. All of that costs a lot of effort. So the model is by itself a so-called digital asset and requires additional protection. And we believe we can do so with our secure execution technology. Now, the beauty is that secure execution does, in this case, not require you to attach an extra PCI-based AI accelerator. We can conveniently use our AI instructions, which are part of our Telum processor. They are located somewhere here on the chip, and they are executed as mere opcodes inside a KVM guest or inside a secure guest. And therefore, they can be readily used. There's no expensive or complicated hardware attachment required, right? You can just utilize any of these AI accelerator functions on the chip directly, no extra steps necessary, and you're not exposing your data or your AI model to any additional risk. So we feel that's a really good story, especially for future usages, right? So with that, we have covered most of the highlights. So this was an abbreviated version of the presentation. I'm just leaving you with a couple of miscellaneous things. So for one, here's a page which summarizes how you can contact us, for instance, in case you have a requirement, either against us or against the Linux distribution partners. So if you want to get in touch with us, here's how to do that. If you have a demand for some change in a Linux distribution, which is not IBM Z or LinuxONE specific, but rather generic, here's a summary of how to proceed with that in that case. Also, if you want to have more information, here's a couple of pointers of various documentation, videos, and so on. And finally, we also have a couple of user forums where you can find like-minded people to chat, to exchange, to share experiences, all of that. So we have the Marist mailing list, and we also have a new forum, which is on the Open Mainframe project. And it's a little bit of a more modern format as opposed to the mailing list, but both are legitimate. I would encourage you to hang out with both. We certainly do, so we'll see when somebody posts there. You can chime in case there's some question there. And that, here's how to stay up to date in terms of our blogs. So you can check those out, and also don't forget to check the longer articles which we posted there. There might be a couple of things which could be of use to you. And finally, some more references towards all of the web pages which we usually frequent and keep our things up to date. In particular, take note of the webcasts. That's down here. And that's basically presentations just like the one you're watching. We do one on average every month and put them up on this page. So if you want to get some good quality content once in a while, I'd also recommend to check it out. So with that, thank you so much for your attention, and hopefully see you next year at the next GSE UK event. Until then, bye-bye.